Morning, everybody. Thank you for attending. We're just going to give another minute or two to let everybody, anyone who's late, kind of slip in, and then we'll get started right away here.
I've got a form I need to sign for their
Can you hear me okay?
Yeah, I can hear you, Chuck.
Okay, sounds good. Checking and yeah, we're getting a lot of people. That's good.
Okay. Steve, ready to go?
Yeah.
Okay. Good morning, everybody. My name's Keaton Cottrell. I'm a marketing coordinator here at ATS Traffic. I want to start today off by thanking everyone for attending. Before we get started, I just have a few housekeeping points to go over. In terms of time, we expect the webinar presentation to take only between 40 and 45 minutes. We'll start off with an introduction from Steve Henderson, ATS Traffic's Director of ITS, then move on to the bulk of the content with Charles Chapman, a technical sales representative from Alpha and Enersys. If you have any questions during the webinar, feel free to put them in the Q&A channel. Then at the end of the presentation, Steve and Charles will go through any questions and hopefully expand or clarify anything that was unclear. Finally, there will be a recording of this webinar along with additional resources that we're going to be sharing afterwards. Okay, and without any more delay, I will pass this over to Steve Henderson.
Thanks, Keaton. Appreciate everybody's time this morning. Thanks again for taking some time out of your busy days to join us. So today we're talking about resilient power for traffic intersections. So as Keaton said, my name is Steve Henderson. I'm Director of ITS for ATS Traffic. And then joining me today will be Charles Chapman. Charles is a Senior Technical Sales Rep for Alpha Technologies. Just a little bit of a bio on Charles. So Charles has 30 years in cable test and measurement, telemetry, command and control. Contributed to the SCTE working groups, to the Standards on Sustainable Energy Action Committee, and chair of the SCTE DSS working group, one on smart cities. So Charles has a wealth of knowledge on the traffic, ITS, and UPS market. So we're glad to have him joining today. So just a little bit about ATS Traffic. Our vision is to get people home safely every day. First and foremost, we are a safety company. It's in our core values, and it's something we talk about every single day. So our mission to be the most trusted industry provider of traffic control products and services, supporting safer and more efficient roads and public infrastructure. A little bit about our reach. So 59 years of experience. Next year, we're pretty excited. It's going to be our 60th anniversary next year in 2026. We are now up to 16 locations, over 8,000 customer accounts. We are a 3M certified sign manufacturer, manufacturing over 1,000 regulatory road traffic guide signs per day. We have a large inventory of other traffic control products and services, 15,000 SKUs in the system. We're now over 700 staff in the company, and then about 68 sales and customer support staff across the network as well. So a little bit about the network. So you can sort of see our nationwide reach there and down into the United States, the Pacific Northwest as well. So from Ottawa across to BC here, I'm based in Surrey. To our ITS office, and then we're down into Tacoma in Washington State and in Portland as well. So we're pretty proud of how much we've grown in the past number of years, and then our nationwide reach. I think we're frankly second to none in the industry on what we bring to the market. Something I think it's important to touch on, and if your municipality is not currently leveraging group procurement, I encourage you to go talk to your procurement office and ask them if this is something you could get involved in. So Canoe Procurement Group, Kinetic GPO, and then down in the States, Sourcewell. These are group procurement organizations. They leverage group buying power, and we're proud to be members of those. They really help cut down on some of the paperwork and process involved in some large procurements, making life easier for all involved. Then a little bit more about us. So ATS, we are, frankly, I like to tell people, we do everything except the asphalt. Traffic management plans, sign manufacturing, as I mentioned, traffic control, equipment rentals, and then selfishly, my division, we are the ITS solutions. So everything from pedestrian safety, like our RFBs, traffic signals, cabinets, controllers, detection, both temporary and permanent, data collection, blank out, LED, VMS signs, and then also lighting, whether that be solar pathway, that sort of thing, even LED retrofits into all of that sort of thing as well. So we're kind of your one-stop shop for traffic control and safety solutions as well. So, and then lastly, yeah, we do have a very robust website that's got all our solutions on there as well. Our catalog is also available online. So our goal to provide the transportation market with innovative products and technology designed to improve the safety and efficiency of both current and future transportation infrastructures. So with that, that's enough of me talking. We'll get to the interesting part of the webinar. Chuck, I'm going to stop sharing and I'll hand it off to you, and we'll let you take it away. Thanks, Chuck.
Okay. Hi, team. Just doing some stuff here. Give me 1 second. There we go. And let me see what I can do here to. I'm going to see if I can take my camera, turn it on. I guess I do need to turn on my viewer. Give me 1 second there. Just so you can start to see me. And hopefully you can now. Yes, you.
Yeah, we see you, Chuck.
Okay. And now what I'm going to do is I should be spotlighted. Is that correct?
Yep.
Okay, very good. Yeah, I'm there. That's interesting. Okay, got it. I just had to pick the right slide. So let's see what I can do about putting myself in this view. So do you guys see it okay?
We see you, Chuck, but there's no slide yet.
Okay. Nope, definitely do. Oh, you know what? Somehow I've got duplicate on. Well, you know what? I hate to do this, but I may just have to share my desktop. I really like to interact with the people more, but that'll work. Okay, so, all right, and just drag this onto my other screen. Yeah, just got some weird screen things going on. And trying to see if I see that. I am a duplicate. That's very frustrating. Okay, so backup power, smart cities, it's more than just reliable power. We at EnerSys are driven by a passion to provide people everywhere with access to power through many, many different ways. As you stated earlier, I've been in the industry well over 30 years, and everything I do, everything I touch has power. And the thing about it is pretty much everything I touch in smart cities. I'm the chair of the SCTE Data Standards Subcommittee on Smart Cities. It all requires power. There's certain elements you need to deliver a solution in smart city, be it smart transportation or anything else. You need a place to put it, real estate, if you will. You need a way to talk to it, to remotely access, change, and receive data from it. And then lastly, you need a way to derive data from it and then power it. So with that, pretty much all the energy systems that we make provides those sort of solutions. So again, everything from renewable energy solutions, industrial, cable, broadband, data centers, and traffic, ITS. So I've worked in intelligent transportation systems for several years, actually working with the Omni-Air Consortium on the CV2X and DSRC development standards and testing, and trying to bring the visibility of the connected future to the people in at that point, the cable industry. We provide all sorts of different things: battery services, enclosures, power, and it's all fully integrated. That's what we try to do: provide not only the products, but the expertise and the resources to get those products deployed and get the value statements realized. So to give you an idea, we've been a company since 2018. We're a manufacturer, 40 years in manufacturing hardened power systems. That's effectively all the Alpha Group made, were things that were hardened. The biggest problem we have actually is the power supplies just won't die. There's over 2 million powered installations worldwide of the Alpha product. Over 20 years of installing ITS and traffic markets. And as you notice, some of these don't look so much like what you'd normally see as a traffic cabinet, but what they're leveraging through ITS affects traffic directly. So surveillance can be shared between traffic and law enforcement, and communications can be shared between many different operators. And when you start talking about connected vehicles and roadside units, a lot of those things are co-located with cameras in order to visually identify further items that may be contributing to the condition. The smart city infrastructure requires backup power. One of the first meetings that we had actually talking about a broadband backed up infrastructure, a gentleman from the DOT commented, "So what you're telling me is that you have a more reliable power grid than the power company." And that's honestly what we strive for, is to provide the bridge between any short-term outages or fluctuations in the incoming power so that we can keep running. When you start to look at smart city infrastructure, congestion is a big deal, right? So trying to look for solutions, congestion is a big deal, costing literally billions of dollars, up to $87 billion, even in 2018. So there are investments that you need to make to decrease traffic, to increase public transportation, to increase the traffic speed, to reduce the CO emissions and other things that are coming from the vehicles, to make intelligent decisions on where you need to do road enhancements or do speed limit changes to make traffic flow more effectively. And of course, you guys know about the intelligent signaling that allows traffic to flow through unimpeded. So again, reduction in traffic congestion and greenhouse gases. If there is no power, there is no data. If you don't have a way of powering the device or powering the backhaul the device needs to get to where it needs to go, you don't have the data you need to make intelligent decisions, real-time decisions, or even AI on-site decisions that require the power of the system. There's an increased reliability of the equipment. This is given by two factors. One is that you are monitoring the equipment. Two is that you're monitoring the power that's powering the equipment. So when a condition happens, well, let's say an extended utility outage, you can jump on in and dispatch a generator to that site before there's actually a long-term outage. There are systems that actually monitor the circuit breakers. So if something actually tripped a circuit breaker, you know not only to go to the site, but what to do when you get on the site. So a mean time to identify, mean time to repair, against creating a greater productivity, quality of life, and sustainability, allowing you to sleep at night and work more effectively during the day. So looking at smart city power, there's many different ways. Of course, we have powering solutions like the FXM and the RBMS for our traffic cabinets. We also have pole-mounted solutions that can provide power that might be only temporary. In a larger parking lot for surveillance or another, let's say for entry or exit or management of the vehicles in there, the lighting circuits actually are very effective places to pick off power, but they're only on for certain parts of the day. If you can create a system that charges during that lighting time and then allows for the power to be resilient during the day, that's a win-win. So backing up IoT devices, backing up all sorts of tolling and access and parking systems. I'm trying to proceed. There we go. That took a while. So when you start to look at it, again, when you look at traffic and battery backup, there's the rugged power supplies, the FXMs that are attached to the alpha batteries that are in the cabinets, and providing the communications to know what's happening in that cabinet, not only at the power supply, but maybe additional monitoring as well. Monitoring the batteries, not only for their voltage or their state of charge, but for their relative condition. There's an acceptance test we do that actually looks at the health of a battery over its lifetime. Again, traffic battery backup in rural locations, that can be done again with mounted cabinets. Parking and security. Parking lots are a huge profit center for many municipalities. So being able to provide them a backup power system that is reliable. A lot of these are now unmanned. So the kiosks, as well as the sentry systems that are watching and the gate control systems that are allowing people in and out, you really can't afford to have a power outage. So backup power is critical. And then finally, for smart city and ITS, the traffic control systems that we have, and we provided ITS solutions both over cable infrastructure as well as remote line power, as well as directly powering it off something like the FXM. Sorry, there we go. So first, the why. Why do I need this? So first of all, the US DOT has a zero initiative to drive transportation-related deaths and serious injuries down to zero. So Road to Zero, there's a lot of different names for this. In Sweden, they have Vision Zero. But effectively, the idea here is to provide an infrastructure and traffic that makes it very difficult for accidents and fatalities to happen. Just looking at online resources, I referenced in 2021, and there were 42,949 people who lost their lives on the nation. It dropped, though, in 2023 to almost 40,000, but still, that's a lot of people. And little known fact that there are at least 8 people or vehicles hit every day by trains. And recently at the ITS show, I realized just how much of a dark intersection can cause a problem, or the lack of a connected infrastructure. I was talking to a larger city that had failed to put in crosswalks with enunciators. So they were being forced to spend about $500,000 to refit their system with the power and such to provide enunciators for the citizens walking across different areas of it. So why do I need a line interactive power supply? The power is not as reliable as it used to be. Power is becoming constrained with things like electric vehicle charging and the data centers that are having the AI draw. Aging infrastructure is making this even worse because what was let's say a tax system is now fragile as well. And then the impacts of renewables. There was a recent study done by NREL that some of the Dallas outages that happened during the winter were kind of impacts of the renewable energy and the fact that during the day their production tends to fall off, and trying to get the other resources to fill in is very difficult. Equipment's becoming more sophisticated. AI's in everything. Definitely in cameras. It's in edge processors for doing traffic calculations. It's in all sorts of sensors. And then we have connected vehicles and V2X and roadside units that those have to be powered and functioning. The sensors have to be functioning in order to provide the information to the RSUs to process. And furthermore, the RSUs have to provide that data to their connected vehicles. If any of that breaks down, you effectively don't have the advantage of having a connected vehicle. And again, dark intersections, accidents, and liabilities are all part of it. Oh, that's what's happening. Sorry, I'm now I understand what's happening. My computer has decided. There we go. And so the next question is, why do I need to monitor my batteries? So batteries are a key in this entire situation. Batteries are a chemical-based energy storage system that allows these routine power edges to be backed up. But if you don't monitor your batteries, that can cause a problem. Battery types are wide. I mean, we used to have just a single type of flooded lead acid battery. It was pretty easy to take care of. But now with even the lead acid, the VRLA versus the TTPL versus the AGM TTPL versus the gel cells, they all have unique charging characteristics, and they all have aging and other characteristics that have to be taken into account. VRLA batteries are affected by temperature. So in order to charge and discharge lead acid batteries, they're temperature dependent. If something happens and a temperature probe fails, that can actually cause the batteries to fail prematurely. And they have a wide range of settings for all those parameters to work. And the other thing is, because of the fact that most traffic solutions use a series arrangement of 12-volt battery cells, if one cell goes bad in one battery, even though the rest of the batteries are fine, that will quickly age and destroy the other batteries in that circuit. And, just kind of getting it, if you look at just the improved safety side, this is a case study that we did. The city of Dallas had a large power outage, and actually they were able to install a uninterruptible power system at all those lights to reduce that sort of thing. Here's another example of remote monitoring and how much that saved. So when you start to look at how many power supplies and how many intersections you have out there, monitoring of that hardware becomes critical, and it allows you to be proactive as well as effectively reactive. So you're proactive in the fact that you see problems before they occur, but you're reactive or more proactively reactive, because when you get an alarm for an outage or something, you have the data to be able to dispatch the right things. Do I need an inverter? Do I need a circuit breaker? Do I need a battery? Rather than arriving on site and then realizing you need that and having to turn around. And in this case study, or this article, they effectively set up in the winter to be able to test this, and they saved so much time. 85 to 90% of the after-hour calls were reduced. So that's, again, another reason to do this. That's the most important part. So the other thing you need is historical information to fill out a battery RMA. Most manufacturers of batteries will require you to have historical data. Again, a reason to have a connected infrastructure with the batteries monitored. Bringing that battery information back allows the people who are going to be handling the RMA to effectively calculate what the problems were. They'll be able to see the rate of discharge. They'll be able to see the rate of aging, maybe even make suggestions to the operator on how to improve. Granted, if these batteries are bad, we'll take them back. But if you change to a slightly larger cell, based on the factors that we're seeing, you should have a twice as long lifetime, that sort of a thing. So there's all sorts of different connected solutions, again, that can work with traffic, that are part of traffic, that are part of a connected ITS infrastructure. And it keeps evolving. They keep coming out with greater things, higher security. That's one of the big things that we're always trying to do, is improve the security of our cabinets, improve the security of our communication protocols. So there's a lot that goes on there. and constantly moving with the market to make sure that you have the products you need when you need them. Probably the largest traffic UPS is the FXM. The FXM was designed for the traffic market. Now, these are shown, they do come with ears, so you can rack mount them. They will rack both vertically and horizontally. That display, actually, there's 4 screws in it, and it's square, and you can actually release those screws, turn it 90 degrees, remount it, and then mount it in the direction that you need to put it in. So pretty much this will operate in many different directions. We generally keep the battery terminals down, but so effectively mounted like this or mounted at the right angle. There are several communication interfaces on this. There's a CAN bus interface. There are 2 Ethernet interfaces, one for local management and one for remote management. There are dry contact inputs and outputs that can be used to provide, let's say, on-site data or on-site notification, like changing the lights to a flash state to reduce the battery draw. That's an easy thing to do. You can also monitor batteries directly from this. There's a voltage sensor. There's a temperature sensor to make sure the batteries are charged correctly. There are many manufacturers and types of batteries previously loaded into it. So when you buy one of the devices, as far as configuring it goes, you don't have to go and read the battery manual for many manufacturers and cell types. But you can just go in and pick it out from a drop-down list. Now, if it isn't there, the options are still there to load the ampere hours and the other items that are necessary. Again, like most traffic cabinets, it's a point-to-point wiring arrangement where your line in and line out can be interfaced very quickly. There are 2 accessories that go with this generally. One is a universal generator transfer switch that allows a quick and easy way to attach a generator to the site. It does have generator priority, so as soon as you get the generator on site, the unit will fall over to the generator and run there as long as you need it. With the universal automatic transfer switch, if anything happened to the inverter, the system would bypass both the input and output and put the energy directly from the source to the load. But you can also use that as a way to test the inverter. You can shut off one of the switches and the inverter will turn on, providing output to the load. If anything were to happen again during that time, the ATS would automatically shut off or take it back from line to load. So big thing is modern encryption technology ensures proper authentication. So unlike the original FXM, the FXM HP has a 256-bit encryption. So it's very secure. It does come configured with HTTP and HTTP access, HTTPS. You can enable and disable those as you need to. You can change the ports as you need to for port forwarding or port routing. It has built-in data loggers, which are really cool. You can go in and pull up data logs very quickly to see how batteries are discharging or how your power input is doing, how many outages you've had. You know, a battery log that shows how your batteries are performing, a performance log on the inverter itself that shows how well it's performing over time, data logs, and then communications. The unit natively supports a web page. It natively supports SNMP access. And to be honest, with that, what else do you need? It has the standard interfaces as you need them for DHCP or TFTP or NTP. Just whenever you need them, they're there. And again, they're very configurable, as is shown in the next slide. So you can configure alarms. You can configure those ports, as I was just discussing. You can set timers. So you can say, I don't want to indicate anything for 15 minutes after the inverter goes on standby, or I don't want to send anything until 15 minutes after the inverter goes into standby, unless the batteries are at less than 60%. I mean, you can put together very complicated, let's say, go, no-go statements into a script, and it'll actually follow that and open and close dry contacts as it needs to. And again, it has multiple user accounts, is falling back to the security aspects. So there is an administrator who can do everything from setting up accounts to operating the units to programming its operation. There's an accounts manager whose only job it is to manage the people and connectivity of the unit. And then there's an operator who, though doesn't have the ability to change a lot of things, has the ability to go in and run tests and view data just as you need to. And again, under alarming, SNMP, SMTP, if you'd like it to go to email. So that is also built right into it. So there's an LCD menu on the FXM HP. It is a color display, way different than the original 2-line LCD display. So it's totally customizable. You choose what you want to view. This is actually the default screen shown here, but I've seen people take the area where the FXM is shown and change that to show the contactor settings. Or they take the configuration and they make the output current shown there. So this is totally customizable. And the way you customize it is not only the LCD display, but also on the web interface. There are setup wizards that walk you through how to configure the FXM system for operation. So it isn't like I have to go in and go to 30 screens and do a particular item. I go through one screen, I click next, I go to the next screen, and then eventually I finish configuring it. And eventually it's only a few seconds, really. It doesn't take me very long. I just effectively set up its operational mode, its frequency, and then I go into the batteries. I choose the battery. I might set the battery name and string name, but then I just choose the battery manufacturer, battery model, and then accept the predefined settings for it. So it's really quick to do the setup wizard. And then the nice part is there's a USB slot on the front panel right next to where that LCD menu is, right next to where the interfaces are for Ethernet. And this USB can be used for many things. I'll be honest, that is a touchscreen display, the LCD, but it's sometimes a little hard to get in and see based on where it is in the traffic cabinet. So what I'll do, I can see it, but I can't really control it. So I'll grab a wireless keyboard and mouse combination, and I'll plug it into the USB. Just like that, I can take a USB drive like this, and I can load it up with firmware for the hardware and for the manager, the display, and I can push it just by simply going in, saying update code and go. But at the same time, using that keyboard and mouse, this is a standard USB port. So I can put a USB hub in it and I can do both at the same time. So it's pretty easy. One of the other factors that's really good about the USB port and the ability to use the flash drive is that you can push backup and send configs. So when you go through all the setups, the battery setups, everything like that, you can copy that off to a drive and then keep that drive in your pocket. And let's just say that the site went down a week later, or that you need to program another 150 sites. You take that drive and you just plug it into the other units. And as long as the hardware is the same, everything uploads and it's all set. The only thing you'd have to do at that point is set the IP address information and set the name and location. That's it. It's pretty easy. There's another really cool display I have called the System Power Flow. This is a real-time running display that shows you the input voltage, the input circuit breaker position, the input voltage to the inverter, the output voltage of the inverter, the load on the inverter, the battery situation, the battery breaker situation. When I say the battery situation, it shows you if it's charging the battery, if it's discharging the battery, how much it's discharging the battery, how fast it's discharging the battery. All of that is shown in this power flow. The other really cool part, and if I have time, I may fall into a movie and show it to you really quick, but the inverter operating mode is shown there. This inverter actually has a way to stay online from a very low voltage, about 85 volts, up to about 150 or so volts. It does that by using a series of taps on a transformer. So it has a line mode where it's effectively super efficient, just connecting the input to the output. But at the same time, if the voltage falls very much, it'll go into a mode called boost. And there are two forms of boost, and it can boost and maintain the range of output voltage, which is like 108 to 120 over 85 volts to 120. And then taking on the other side, there's a buck system, which is another set of two taps that will allow it to go up to like 150 plus volts. And all it does, it just changes the taps and keeps the output right around 120. It's remarkable. And the system is very easy to use. It has configuration for its operation. So even though you may see the inverter go on, if it becomes a problem, you can diagnose it, maybe fix the electrical system. But if it's unfixable, you can actually change some of the ways that the FXM HP operates. You can tell it to wait longer to reconnect. You can tell it to qualify the line as a generator rather than an AC power line. So it's a little more acceptance of frequency changes or something that might be completely rejected in normal mode. So there's a lot of configuration you can do, and you can gather a lot of information, and the log files allow you to compile that information and visualize it. You can also add peripherals. We haven't done a lot of this, but because we have the CAN bus connection, we can connect other devices to it and bring in additional features. Now, granted, we already have 6 dry contacts. And we have a high count of inputs as well. And then finally, pretty much everything is customizable. You can configure the data logs. You can export the data as CSV. You can customize the alarm limits, set which ones are active, which ones, what the levels are for active, all sorts of different things. So I think I'm doing okay time-wise. I thought I would leave us a little time at the end. Let me pop out for a second. And I'm going to stop sharing. If I can ever find my mouse again. There we go. There, so now I'm back in the meeting. Now, let me see if I can get my camera fixed here.
While you're working on that, Chuck, I'll just let people know if there's any questions, you can drop them into the Q&A tab. And happy to answer those. Chuck, did you have any further slides?
I can go in, like I said, I had a short movie that I can show that
Sure.
kind of goes through the operation of the FXM. And,
Yeah, we've got some time for that. If you
okay. Yeah, give me 1 second here. And I am trying to compile some additional movies. Our former person, our former traffic person, did a lot with movies. We had the short clips, and I'm trying to keep that tradition going. I think it was really a good thing. Mike Olson was great to us with that, and he really made things happen. There we go. Now I'm fixed. And now let me see if I can get to this movie. I had it open earlier. There we go. And here we go. So I'm going to turn myself down and show you this. This is a movie of the actual operation of the FXM, going through controlling those input AC conditions and maintaining the traffic signal. By the way, I'm just going to pause it for a second. Can everybody hear that?
There's actually no sound, Chuck.
There's no sound. That's what I was worried about. Okay. Hold on a second. You know what? Maybe I can just, I'll just voice it over. So I'll go through the FXM and can you hear me okay though?
Yeah, I can still hear you.
So the important thing is that the FXM will maintain the power through through any of these different operations. And sometimes things don't work out the way you want it to. Let me see what I can do here. Okay, so that's an FXM, right? So I'm going to pause this for a second. So the FXM's in the top, and this is in my lab, and they're all set up. So what you can see, there's a couple of items that are actually kind of important here. And hopefully I can highlight it with my mouse enough so that you can see it. So we have the input voltage, the output voltage, the line operation mode. Now, as you can see, I have no alarms. Now, the alarms will only show up when a condition requires action. So other modes may not create an alarm unless you tell it to, but the actual running on inverter will create a running on inverter situation or event. So that's all shown here. As I talked about, the dry contacts from C1 to C6 are shown underneath it. There are also user inputs. So along with the dry contact outputs, or effectively form C closures, there's also a user input. Underneath that, there are two items. One is on this side, that is the automatic transfer switch that takes the utility in, provides a bridge up to the FXM, then takes the output of the FXM, runs it back through this bridge. Now, what this does in normal operation is it provides power to the FXM and then takes the power from the FXM and gives it to the load. But if something were to happen to the FXM, it will directly connect the input to the output, not creating an outage. Our transfer time on the FXM is less than 3 milliseconds, so it generally can't be detected at all. So it's a good thing. The other box on this side is a universal generator adapter. And what that does is that allows us to bring in a generator source and have that generator source provide power. And the only time that would fall off is if the generator failed. So effectively, generator fails. If the AC is available, it just goes right back to it. So it's all good. But what I'm going to do is I'll go ahead and keep this playing. So we'll go back to that for a second. And you can see I'm actually highlighting those areas I was talking about. This is where the menu is touch screen and you can control it and actually set to the different items. And then there is a home button that I pressed right before I left. And again, what we're going to be looking at primarily is the input voltage, the output voltage, and the line operating mode. The output current shouldn't change much because the output wattage, because the output voltage is staying very constant and the load doesn't change dramatically. So it should. So what I'm going to do is I'm going to bring up a view of the web interface. So we're going to log in using the credentials. And now that I'm into the FXM, I'm going to go to one of my favorite things, which is the power flow diagram. You can see the menus there on the top, showing it's a little different display because it's a 6 on the bottom and it's a 4 on the top. But this is the power flow. Get to it by clicking on power flow. And you can see there that I have my AC input source, my input circuit breaker, and then that follows through to the actual functioning of the FXM. Now, one of the important things about all this is my traffic light. I need to keep my traffic light in place. So now I've replaced the load with a visualization of my traffic light. So to go in, I have my input voltage. I'm running in line mode. So what you'll see is the input voltage and output voltage will almost exactly match. And I can vary that slightly. I'm actually breaking it up slightly. I took it from 116. I'm getting right on the cusp of 120. And everything's operating fine. Again, it's not going to do anything unless it's necessary to do. And I'm going to go ahead and highlight the areas that I want you to follow when I do this. So there's my input voltage. Frequency is also there. Output voltage and the frequency or the power. The operational mode in line. That's the battery draw. So we have pretty much the view of all the energy and operating modes of the system. Now, again, it's running at 120 volts, so life is good. There's no issues. This is the way that most traffic signals run most of the time. It's not normally an issue. But let me go ahead and start to turn the unit down. As you see, I'm down to 114, and I'm going to start to lower it slightly. Once I drop it below, let's say 105 volts or whatever, you should see it go into something. There you go, 109 volts. I'm into boost one. So I've got 109 volts in, but the traffic light doesn't see anything but 123 volts. Life is good. That's the idea behind a line interactive inverter, is that it provides you the power that you need when you need it, and at the most efficient way of delivering it. And the cool part is, let's just say this was right after a major outage. I'm running on the utility because it's available enough, and I'm also still charging the batteries. So I'm recovering the batteries as well. That's the nice part about this. Anytime we stay connected, it works. Now I've gone to boost 2. I'm at 94 volts on the input, still maintaining between 116 and 120 in the output. And then eventually you'll see it go to fault. Then the inverter will go on. Now I might hit retransfer because I didn't turn it quite enough. Let me turn it down just a slightly bit more. There we go. Now I'm constantly on the inverter. I am now running on the batteries, and you can see the difference in the draw curve. And I'm still sending the 120 volts exactly to my light. So nothing affected that. So I can also turn the voltage up. Now I'm turning it up, went to buck, and now I go back to normal. So if I shut off the input, this is what it does. I end up with 0 and immediately goes on burn. There is no outage, there is no glitch, and the output is maintained. So this is what it's designed to do in a traffic cabinet. Just a quick overview. I'm sorry the audio didn't work from it, but it does give you a really, really good idea of how this works. And I'm open for questions if anybody has any.
Thanks, Chuck. I'm just going to quickly share my Q&A screen.
Oh, let me turn my volume up. I'm sorry, I turned it down. Try again. I'm sorry.
So there is a question in the chat from Jerry. Hey, Jerry, thanks for submitting your question. So Jerry says, if a FXM fails in the field, is there a good way to use the dry contacts to trigger an alarm to signal? In other words, would have the contact closed in normal operation, but opens upon FXM failure.
So there's a couple ways you can do that. Probably one of the best ways actually is to use the transfer switch. There's a couple of ways you can do it. The thing is, when you say the FXM fails, it depends on exactly how it failed. If it fails catastrophically, you could use the 48 volts as a sense. You could pick that up. And if it fails severely, actually the UATS, there is a model that has a dry contact on the front. And as soon as the UATS is activated, that closes that closure. There's actually an input on the FXM for that, but you could also use it as an additional output. Does that answer your question?
Jerry, I hope that answered the question for you. You can give it a thumbs up if you want. Are there any other questions? I don't think people are able to unmute, but there's a question in the chat. So
at the top of the season, you highlighted safety in dark areas. Do these cabinets control intersection lighting? So the FXM is agnostic to what it's controlling. If you have some lighting that is within the operational mode of the FXM, sure, you could run lighting with it. That's not a bad idea. And that's the thing is, I'm a smart cities guy, so my thing is, what works the best, right? If there's a solution to a problem, that's what I look for. And sometimes there's very elegant solutions for that. And that's actually a good point. I was talking to several companies at ITS that made different forms of lighting. Some of them were for LPR lighting, intermittent lighting, but others were just for area lighting. And a lot of times the new LEDs don't take that much. They could run on PoE or PoE plus at less than 50 watts. So yeah, I don't see why you couldn't have lighting plugged into that also. But again, if it's 277 volt or something like that, you'd have to use some form of step up transformer because we're set at 120. That's a great question though.
Is Alpha offering super caps in place of batteries?
So yeah, super caps are one of my favorite things to talk about. So we don't have a super cap per se. The thing about a super cap is that it is, they don't like to say it, but it's still kind of a lithium battery, but I don't want to get into that here. So there are many offerings for those out there. We are investigating new powering infrastructure all the time. I don't know what our time frame is on delivering that yet, but that's a great question. And thank you for posting my stuff in there. Yeah, there are advantages in any form. I mean, lead has advantages, supercaps have advantages. Um, the one of the big things with lead actually is that it's recyclability. Because of its ease of recyclability, its cost of recyclability, and its availability to recycle, there's huge recyclability things in lead. But there's always new technology coming out. Solid state is also coming out. There's several offerings in that recently. So I know there's a lot of discussion internally about the offering of additional energy resources like that. But I'll ask my team again. I'm not aware of one currently that we are offering. Yeah, and I'd say for any, this is just a comment, for any non lead acid battery system, non-lead acid or nickel cadmium, the primary programming in the FXM currently is around lead, right? There are temperature compensations or other things. I actually have a large background in energy sources that are not traffic. I'm a NABCEP, North American Board of Certified Energy Practitioners, certified in PVA and storage, and I work with SEAC also, the Sustainable Energy Action Committee. So the only thing I can tell you is that most of these newer storage technologies do not require temperature compensation. That being said, the FXM has a setting in it for setting the temperature offset. I would definitely, if you're using something other than lead, set that to 0, but do not disconnect the battery temperature probe. Leave the probe attached because if you don't attach it, it may perform an offset just based on the fact it doesn't see the probe. But if you set the temperature offset to 0, that should make it more compatible. The other thing is most of those systems are controlled by a BMS. So you need to make sure the operating mode of the FXM will fail before the BMS trips. If the FXM operates outside of that, then you'll have to go and reset the battery every time it goes to that.
So, Chuck, are you strictly offering lead acid, or are there other battery types available?
I believe for the traffic currently, we're just offering lead acid. We do have lithium in other verticals, but we haven't adopted one for traffic yet that I'm aware of. And again, we're a pretty modern company, so the reason I keep quantifying my answer with that I'm aware of is that they could come out with it tomorrow. I don't know.
if there are no other questions, I'll thank everybody for attending. Chuck, thank you again for your time. Thanks everybody who is on the call here for attending. And I'll just add, if anybody needs any further information, our contact information, mine and Chuck's is in the chat there. Alternatively, you can reach out to your ATS traffic or interprovincial rep in whatever region you happen to be in. And yeah, with that, we'll wrap this up. It will be shared, as Keaton mentioned off the top, on ATS's YouTube channel. So if a colleague hasn't been able to attend, feel free to look for that later. And yeah, thank you everybody once again.
Thanks all. Have a great day.
Thanks, sir.